Hello friends and DIYers, welcome back to the DR100 Watt Concept Project Microcontroller Programming section, and you are watching episode 2. In this video, we will continue the programming simulation with added flavoring in our program as we progress, and let's do that after my intro. In the last video, we talked about installing the IDE, the BASCOM 8051 IDE, how to use the IDE, and how to write our very first program using a bit command to control port 3, bit 6, or P3.6 from logic 1 to logic 0, and that it seems to be very simple. If you have not watched episode 1, you might like to see it first before continue watching episode 2. What's up guys, welcome back to the DR100 Watt Concept. Now, let's command the MCU by alternately instructing it to ghost logic 1 and logic 0, which the effect of it is like a blinking port. To make it more interesting during our simulation, let's imagine that there is an LED connected to P3.6 in the current sync configuration. It looks like this. When a logic 0 is instructed to the MCU by commanding it to P3.6 is equal to 0, then the LED will light up, and when the logic 1 is instructed by commanding it to P3.6 is equal to 1, then the LED is turned off. Let's see that quickly. The P3.6 is equal to 0 cause the MCU port 3 bit 6 to ghost logic 0. The delay, wait MS50, is chosen for a better simulation view. The next command is that the P3.6 is equal to 1 cause the MCU port 3 bit 6 to ghost logic 1. And finally, another delay, wait MS50, before it goes back to the instruction P3.6 is equal to 0 by the action of the do loop endless loop instruction. Now it's the time to simulate the program. Let's try to simulate it and let's see the effect. Let's start by pressing F7 to compile the program, then F2 to enable the simulation, press the hardware emulation, and finally press the play icon. Watch P3.6 behavior on the port window. You will see that it looks like it's a blinking LED. You will notice also that the program tracer is running back and forth between the do and loop instruction, and any instruction inside the do loop is being executed. Once again, if you look at the P3.6 port, it looks like it is blinking LED. You may go back to the text editor and try to change the delay from 50 to 100 maybe, or maybe 80. Let's try to do some kind of experiment and let's see the effect. Just take note that this is a simulation environment and the 50 millisecond was chosen for a better viewing just in the simulation, but this 50 millisecond may not be appropriate in the real world hardware. We will see that when we are in our real world hardware environment. For the time being, we are in our simulation environment. Let's just take note of those pointers for simulation. What if I want to blink all the ports of P3, or maybe the question is, what if I want to blink all the 8-bit ports of P3? Well, that is easy by using a byte command like P3 is equal to NB 0000000 8 zeros, which caused the whole port to ghost logic 0 at the same time. But wait, where is this command or instruction came from? Basically, that is the format of BASCOM 8051 in the binary notation in byte command. The P3.6 notation is used when we command the MCU for only one port, meaning we are only dealing with one pin of the MCU. I normally call this as bit command, simply because I only command one port or one pin of the MCU. But when we want to control several ports in one instruction, we access the port in byte or 8-bit at the same time, and this instruction in binary is a byte command. Well, you can see that the instruction is AND B 0000 zeros, and the B notation means it is in binary notation. Alright, so for commanding port 3 to ghost logic 1 in 1 byte or 8 bits, I use the instruction P3 is equal to NB 11111. There will be 8 ones. It means you are telling the microcontroller that all the ports in P3 goes logic 1. This time, I'm using a binary notation because it is easy for me to understand about the ports when logic 1 is simply means 1 and logic 0 simply means 0. Let's continue by simulating the program, and here you go. You will see that all the ports of P3 or the 8-bit ports of P3 is being commanded by one instruction to ghost logic 1 and logic 0 at the same time alternately. For the record, since we use binary here, let me just mention that a decimal number can be used as P3 is equal to 0 for logic 0 and P3 is equal to 255 for logic 1. The binary NB 00080 is equivalent to 0 in decimal, and the binary NB 1111181 is equivalent to 255 in decimal. Whichever is easy for you to figure out, you have the option which notation to be used. For me, binary is easy to imagine as the following. 1 means logic 1, 0 means logic 0. Following that idea, so when I want to command P3 as follows, NB 10101010, it simply means that the 4 bits is logic 1 alternately and the other 4 bits is logic 0 alternately. Isn't it that easy? So our next program will be like this. Alternately put 4 bits into logic 1 for a given time and the other 4 bits into logic 0 for a given time. The effect is making the 8-bit port at P3 looks like a running LEDs if we assume that there are 8 LEDs connected to these ports. Let's see that. Well, what do you think? While running our program into the onboard simulator, that is a program for, let's go back to the text editor window, and you may notice that there are commands in the program in blue color. In BASCOM, it is started with an apostrophe like this. Commands is standard for programmer to add some important notes for remembering important items, or maybe something you want to express your feeling at the time of doing the program, like this. Remember that commands are welcome to make the program readable and easy to understand, just don't overdo it. Well guys, this is gonna be the end of episode 2. I hope you learned from it. If you like to know more about simulation, the BASCOM reference manual will tell you more about simulation and how to use it effectively. For now, stay tuned to this channel for episode 3 as it's on the way. It's the adventure with a 20x4 LCD, the human-machine interface. If you haven't subscribed, you might like to support my tutorial by subscribing to this channel. Share your circle of friends who might need it, especially for those audio hobbyists and DIYers who would like to build a powerful human-machine interface. Thank you for your support. If you have questions, kindly leave by commenting below. I'm looking forward to serve you better. Bye for now and see you in the next video.